And God said, "Let there be light." And there was light. But what exactly did he create? One big giant fireball? Well, yeah. Every day that giant fireball we call the sun rises from the horizon, and by the end of the day it sinks again, leaving us in darkness. We all know that light travels. Trillions of small beams of light fly through space, crash upon Earth, and bounce back into our eyes. And that's the way we can see the world around us. The explosive energy of the sun shoots light particles outwards at high speed. These light particles travel out in all directions like a wave. If we hold a whiteboard towards the sun, we can bounce those particles in different directions. This is called reflecting the light. When you're just standing outside, you're not only lit by the sun, but also by many reflections around you. The most obvious reflections come from the ground you're standing on. So if you would stand on a darker surface, you will be lit less than if you would stand on a brighter surface. Darker objects don't reflect all the light particles they receive. They absorb most of the particles, as where lighter objects reflect more of the light particles they receive. Okay, we know that light can be reflected, but it can also go through objects. When we hold a paper towards the sun, we can see it leaves a shadow. Two things are happening here. The paper reflects a bunch of light and it lets some light through. That's why we see a shadow. We are not getting the same intensity as part of the light is being reflected. Now, the light that isn't reflected doesn't just float through that paper like a ghost. No, it actually bounces in many directions against the fibers of the paper until it reaches the other side. This means that the light is not coming out straight from the paper, but from all directions. This is what we mean when we talk about soft light. When light gets reflected, it takes the color of the object with it. So if we take a green object, the reflected light will also look green. Now, the Earth has a protective shield called the atmosphere. This also means that the sunlight has to go through a layer of gas molecules before it reaches us, down at the ground. In other words, the light we get is reflected. And that's exactly the reason why the color of the sunlight also changes. During a sunrise and sunset, the light looks more orange or a lot warmer, as we also say. At these times, the light travels through more atmosphere before it reaches us, changing the color. A very common term for this among filmmakers is the golden hour or the magic hour. That's the last hour the sun is above the horizon, leaving a beautiful golden color over the earth. But there's more. When the sun is below the horizon, it can still reflect its light to the atmosphere. That's the point we call the blue hour, the final hour before the actual darkness hits us. At that point, the colors are very bluish, or they look cold, as we say. And that's why we link blue light to cold nights. That was it for this video. We've seen that any object reflects the sunlight. Some of these objects reflect more than others. There are even objects that let the light go through, but they diffuse the light as the particles bounce around through the object. Finally, we've seen that the reflections that happen also always change the color of the light a little bit. And that the atmosphere is a weird and wonderful thing, giving us gold and blue colors. In the next video lesson, you'll see how a basic lighting setup is accomplished. Thanks again for watching.